This is a very important lesson, probably arguably one of the most important lessons in the entire curriculum because there's always one FRQ question on the AP exam and multiple choice questions that are related to this concept here, which is some calculus and physics. So Mr. B is playing catch with his best friend. He throws a tennis ball straight up in the air, if you're following my mouse, and then it goes down. The height of the ball is modeled by this function here, where s is the height of the ball and t is time. So we're given the position function. Right when you throw the ball, you're going at a high velocity, it's moving quickly. But then it's eventually slowing down. You can see at about like this point right here, that's the highest the ball reaches. So that corresponds with the velocity of 0. So your velocity is highest as first, and then it's slowing down gradually. The velocity is going down gradually. Velocity is just speed and direction. So a positive velocity means you're going up. A negative velocity means you're going downwards, right? And notice here the acceleration is always going to be constant because if you guys recall, force of gravity is about negative 9.8 meters per second squared. It's a constant acceleration. So the relationships between position, velocity, and acceleration. The velocity function is the derivative of the position function, s prime of t, and the acceleration function is the first derivative of the derivative of the velocity function. In other words, the second derivative of the position function. You have to memorize these. This is so important. You have to have this memorized. So velocity is equal to the rate of change of the position. If velocity is less than 0, if velocity is negative, the particle is moving left or down. Left slash down, one of the two, depending on the context of the problem. If you're dealing with height, such as this example, right? A negative velocity means you're going down. But sometimes you could be dealing with problems that are you're moving left or right. And in that case, a negative velocity would mean you're moving to the left. If a velocity is positive or greater than 0, it means you're moving right or up. Right slash up. If velocity is 0, it means the particle is at rest, not moving. To calculate average velocity, same as thing as the average rate of change. Average velocity over a time period it's like y2 minus y1 over x2 minus x1, just in the context of the position function and the physics problems. Should look really familiar. And this is on the interval a comma b. So if they ask you for the average velocity from the 1 second mark to the 5 second mark, you take your position, subtract them, and then subtract the times there. And speed is just the absolute value of velocity. So if you had a velocity of -5, speed would just be the positive version of that, which is +5. If velocity is +10, it's positive already, so the speed is also +10. Again, these are very important to memorize. Gotta memorize all these. I cannot stress the importance of understanding everything in this lesson. So speeding up or slowing down? Again, these are two things you have to memorize. If velocity and acceleration are the same sign, a particle is speeding up. If velocity and acceleration are different signs, the particle is slowing down. for example, if your velocity is upwards, right? You're going up, positive velocity, and you have a positive acceleration, and someone's like pushing you from behind, you're speeding up, speeding up, speeding up. However, if your velocity is positive, but it's like someone's pushing you down, you're going to be slowing down. So just remind here that just know if velocity and acceleration are the same signs, the particle is speeding up. If velocity and acceleration have different signs, the particle is slowing down. So if you look at here, right, at t is equal to -5, the particle has a positive velocity, negative acceleration. Therefore, particle is slowing down. Here, opposite signs too, slowing down. Here you have the same sign, so speeding up. At 4, because they are both negative, the same sign, speeding up as well. So displacement is the net change in position. So displacement is just the difference in distance like from where you start and where you end. So let's say like Mr. Lou, I'm right here, right? That's me. Let's say I take 5 steps forward. I take 5 steps forward, and then let's say I take 2 steps back, right? I took a total of 7 steps, so total distance traveled, was 7 steps, but my displacement, I only ended up 3 steps from where I started. You'll see a lot of questions on the AP exam and on tests about displacement versus total distance traveled. Keep these very clear. Displacement versus total distance traveled. Because here, again, my total distance traveled was 7 steps, but my displacement was 3 steps. Because from my starting point to my end point, there was just a difference of 3 steps. Let's go to the next page. Particle motion from an equation. So the position or x-coordinate of a particle moving on the x-axis is modeled by the function for t values greater than or equal to 0, where x is measured in cm and t is measured in minutes. So because it's the x-axis, we know the particle is going left or right. If it was the y-axis, it'd be going up or down. So find the displacement of the particle during the first 2 minutes. So what we want to do is find where the position is at the 0-minute mark and the 2-minute mark. And then we subtract them. X of 0, you just plug in 0, 0 minus 0 plus 3 is 3. And then x of 2 is equal to, the position at 2 is 2 cubed, which is 8, minus 4 times 2 squared, which is 16, plus 3 is equal to -5. So you take your position where you ended, x of 2, minus the position from where you started, x of 0, you get -5 minus 3 equals -8 centimeters. So displacement. -8 centimeters because it's negative because I'm a distance of 8 to the left from where I started. Find the average velocity of the particle during the first 2 minutes. Average velocity, it's the average rate. Think about velocity as rate. So x of 2 minus x of 0 over 2 minus 0. So it's -5. Well, we already had -8 from 4 over 2 equals -4. And the unit will be, well, the position is measured in cm per minute. That's the average velocity during the first 2 minutes, moving a -4 centimeters per minute. So in other words, you can say you're moving left 4 centimeters per minute, the particle. Find the velocity of the particle when t is equal to 4. So again, velocity is equal to the derivative of the position function. So the derivative of x of t here is 3t squared minus 8t, and then v of 4, or x prime of 4, you just plug in the 4 here. 3 times 4 squared, which is 16, minus 8 times 4, which is 32. That gets you 16 centimeters per minute. So the velocity of the particle at t is equal to 4 is 16 centimeters per minute. Find the acceleration of the particle when t is equal to 4. You want to find the acceleration function, which is the derivative of what you got for the velocity function, which is 6t minus 8. So a of 4 is just equal to 6 times 4, which is 24, minus 8, which is equal to 16 centimeters per minute, or you can just write centimeters per minute squared. So is the particle speeding up or slowing down at t is equal to 4? Justify. So we see here velocity and acceleration are both positive, both the same sign. So the answer is speeding up because velocity and acceleration have same sign at t is equal to 4. Something like that there. All right, some graph, this last example here with a graph. The figure below shows the velocity of a particle moving on a coordinate line. So careful here. This problem here, you're given the velocity function. Was it on the previous page? Like this first example here was the position. This is the velocity. It's different because problems can give you the position function or the velocity function. So you have to be careful what you're given. So this here is the velocity function. So when is the particle moving to the right? So if you just think about the terms from your previous page here, right? The particle is moving right when velocity is greater than 0. So I can just write that down right here. Let's see where I want it. Moving right when v of t is greater than 0. And this happens, so greater than 0, which means positive. So wherever on this velocity graph where you're above the x-axis, the t-axis in this case. So you see that's from 0 to 1. You see from here to here, this is all above the horizontal x-axis here, 0 to 1. And you see from here, this graph is all positive. The velocity graph here is positive, so that's about 4.8 to 7. So when's the particle moving to the left? I'm not going to rewrite it again, but it's just whenever vt is less than 0. And that's when the velocity graph is negative, below the t-axis, the x-axis. So that's from 1 to 4.8. They asked to justify. You can just say because v of t is less than 0. When is the particle's acceleration positive, negative, and 0? So this is the velocity graph, right? Acceleration is equal to the derivative of the velocity graph, or the slope of the velocity graph. So you see this line segment here, right? From here to here. Acceleration here is negative because the derivative is negative. The slope here is negative for the velocity graph. So we can write from 0 to 2, like from here to here, the slope's all negative for velocity. Therefore, the acceleration is negative at that point. From 2 to 6, you see the velocity function, the graph here is positive. velocity is increasing. The slope of this tangent line is positive, so therefore from 2 to 6, acceleration will be positive. Acceleration's velocity is increasing here, so the acceleration or the slope is positive. And then from 6 to 7, velocity is decreasing again, so acceleration is negative. And there's no flat horizontal tangent lines here, so right here there's none for the zero acceleration. There would have been a zero acceleration if the graph looked like this. Here, because there's a horizontal tangent line, that would be acceleration of zero, and here. But since these are like sharp corners and turns, we do not have any zero accelerations. All right. When does the particle have the greatest speed? Anytime you see greatest speed, again, speed is absolute value of velocity. So pretty much if you have the velocity graph, you just need to find the lowest point on the graph and the highest, lowest and highest. So see here we have a velocity of positive 2. Here we have a velocity of negative 2. So it's asking when. Not what is the greatest speed, they're asking when does it have the greatest speed. You see at 0 and 2, the velocities are both, well, the speeds are both 2. Because the velocity here is 2 when t is equal to 0. Velocity here is negative 2, which is a speed of positive 2. So that's when t is equal to 0 and t is equal to 2. When is the particle speeding up? The particle is uh, speeding up when velocity, I want to say velocity acceleration for short, are same signs. And then here, when's the particle slowing down? Slowing down when velocity or acceleration and acceleration are opposite signs. So we're gonna have to look at this. Let's do this segment by segment. Typically you want to take every piece. Like this is when you have the slowing down and speeding up ones, you want to look at every piece that's above and below the x-axis. So from here, we have to determine whether this is speeding up or slowing down. At this segment right here, you can see velocity is positive because the graph is above the x-axis, but acceleration is negative because the slope, we're going downwards. So that's there. For this one segment right here, you can see that velocity is less than 0 because it's below the x-axis, and then the slope here, acceleration's negative because velocity is decreasing here still. So in this segment down here, the particle is speeding up because velocity acceleration are the same sign. And then right here, velocity and acceleration are opposite signs, therefore slowing down. I want you to pause the video right now, try out this segment here, try out this segment here, and try out this segment here. All right, just double check your work. This segment here, velocity is less than 0, acceleration is greater than 0. This segment here, velocity is greater than 0, acceleration is greater than 0. And then right here, velocity is greater than 0, but acceleration is less than 0 because velocity is decreasing here. So when's the particle speeding up? That's when they're the same signs, and that happens from only two places here. 4.8 to 6. It's like from 4.8 to 6, and then also from 1 to 2. let's see here, scroll down a bit. When's the particle slowing down? Well, the particle is slowing down from 0 to 1 because, velocity and acceleration are opposite signs. From 0 to 1, comma, 2 to 4.8, and also last one, 6 to 7. This was a long lesson here, but I cannot stress the importance of it, so you can go ahead and take your time with the practice.